Welcome back to Introducing Polynomials. In this video, we will be exploring multiple of the tiles. So how would I represent this? Take a moment, pause the video, brainstorm some ideas how you might name this as a total area. So I know that this is one X tile. It has a dimension of 1 and it has a dimension of an unknown number. And I have a second X tile. And when I have two together, that means they must be the exact same. So I have one X tile and one X tile. So altogether I have two X tiles. So I can represent this as 2X. What would be the value if X was actually 7? This would have an area of 1 multiplied by 7. So that would have an area of 7. And then this would also have an area of 7 because it must be exactly the same. But I can check it. 1 multiplied by 7. So I have two tiles with an area of 7. 2 multiplied by 7 is 14. 2x equals 14. How would I represent this as a total area? Pause the video while you figure that out. Well, this is x squared because it has dimensions of x multiplied by x. So I have 1, 2, 3, 4x squareds. So I would represent that as 4x squareds. So what if x actually had a value of 3? What would be the total value of this? Well, if this square has dimensions of 3 and 3, that means that this area must be 9. 3 multiplied by 3 is 9. So I've got 1 9, 2 9s, 3 9s, 4 9s. 4 multiplied by 9 is 36. So the total area would be 36. Take a moment to consider this statement. Do you agree or do you disagree? I have 3 x's and I have an x squared on my table. The statement that you are agreeing with or disagreeing with is, this can be short formed to be 5x. So I could take my 3x and my x squared and combine those together and say I have a total area of 5x. Do you agree? Do you disagree? Explain. Pause the video while you think about that. Well, let's see if this is true. So I have 3 x's and an x squared, and we're trying to figure out if that would be the same value, the same total area as 5 x's. So let's think about this. I'm going to make some notes as I go down here to help me keep track of the math in my head. I'm going to pick a number for x. Doesn't really matter what it is. I'm going to keep it nice and small so that the math doesn't get too complex in my head. Let's say that x equals 4. Well, I want to know if 3x plus x squared, the answer to that is the same as the answer to 5x. So 5x would be equal to 5 multiplied by 4. Well, 5 sets of 4 would be 20. So now I have to figure out 3x plus x squared. So 3x plus x squared would be 3 sets of 4 plus 4 squared. And I didn't need to put my 4 in the brackets, but just to help keep it separate, I thought I would do that. Well, 3 multiplied by 4 is 12, and 4 squared is 16. 12 plus 16 is 28. So I can see there that those are not the same. Feel free to go and test that with other numbers. Can you find a situation where it would be true? It's always interesting to find those numbers where you can actually make that work. You can't just take 3 x's and x squareds, squish them together and say that you have 5x. Here's another way to look at that. We are saying that 5x would be the same as 3x plus x squared. So let's take my 3x's and we're going to put them here, right beside each other. Now I said that all of that would be the same as 5x, which means that if I put 5x's below that, I'm just going to duplicate these. And I know I didn't really need to reduplicate the 3x because it should match up. And then put 2 more x's in here. I can see that that really doesn't make any sense either. But the best way to actually prove it is to come and do the math that we did to start. The thing you need to remember is that when you are trying to combine terms, when you're trying to combine tiles, you can't take your x's and add them in together with your x squareds. You have to figure out what the actual areas of them are first, and then you can add the areas together when you're done. So that's the end of this video. Hopefully you found it helpful, and we'll see you in the next one.